Hello, I'm Peter Bell, and I'm here with Quinn Harper, Chief Geologist of Serengeti Resources. Hello, Quinn.
Hey Peter, how you doing?
Very good, thanks. I gather that you have a presentation here for us about everything going on in the company beyond KWANIKA.
Yeah, that's right. More or less, we want to, a lot of attention in the last 10 years has been focused on bringing KWANIKA to the next phase. And now that we've got a strategic partner in POSCO Daewoo and launching into a pre-feasibility study, it's Serengeti's starting to look at, not that we haven't in the past, but really seriously looking at what we're going to do to find another one.
Wonderful. And I gather that this is a presentation you gave at the recent Kamloops Exploration Group conference.
Yeah, that's right. It's just a slight variation.
So for the audience who may be watching and wondering what to expect some geology.
Yeah, that's right.
Thank you very much.
Perfect. So I'm Quinn Harper, Chief Geologist for Serengeti Resources, and yeah, essentially I'm going to talk to you about what we're up to in 2018, everything beyond KWANIKA. So as I said, KWANIKA is going through a pre-feasibility study right now. There's significant value upside at KWANIKA as well, but we wanted to fill our pipeline as well. And basically give ourselves the best bet of making another discovery. So we'll go through that here. I will be making some forward-looking statements through this presentation. And of course, this is exploration. So here's just a quick snapshot of the corporate structure and share structure. In the presentation, I'm going to be focusing on this portion here, the project pipeline, yeah, we'll see if we can show something to everybody here. So what we've been up to so far in 2018, it's April now, so for the last 3.5 months or so, we've made several significant acquisitions, the main one being the Atty property, which we optioned from Finlay Minerals and Electrum Resources. Atty lies directly north and adjacent to the Kemess claim group, right up in this region of the province here. And we have KWANIKA here. And we've also picked up 8 other properties through online staking based on the Geoscience BC Search 3 data that was released during Roundup late January 2018. And it's kind of hard to see on this map, but zoom in a bit. You can see all of our properties are outlined here. Anything in the square dots are the Search 3 properties.
And Quinn, if I can interrupt for a second there, just to point out the number of properties that you guys staked there, 8 in addition to the 10 you already had. Wow, I was really impressed when I really appreciated that recently.
Yeah, definitely, and they're all they look great. I mean, we picked them up for good reason. Some of them have, I would say, half have historical work on them already, assessment files that we can pull data out of, and or which we have pulled data out of prior to the release of the Search 3 data. And once that was released, then we really focused in on some areas and managed to pick up 8 properties. So we'll continue on. So we'll look at Atty first. Essentially, the Atty property is about 4,500 hectares. It's directly north of Kemess, and it connects to our UDS property, which we staked in 2013, just on the west side of UDS. So the combined land package now with UDS and Atty is, I believe, approaching 6,800 hectares, and it's right in the heart of the Kemess porphyry district there. So we're really excited about that. So as far as the Atty option arrangement goes, more or less it has 2 parts. The first is the exploration and property interest expenditures. So Serengeti has the option to acquire 100% of Atty for a total of 12 million in exploration expenditures over 8 years. Our 2018 exploration commitment is 300,000. Also, aggregate cash payments of 625,000 over 8 years, and cash or share payments of 975,000 over 8 years. So we've got a decent amount of time here, 8 years to figure out if it's something we like, if there's something there. Really, the agreement is sort of back end loaded, so we get in fairly light in the first few years, 300,000 in the first year, 900,000 in the second, and 1.2 million in the third year. By the end of the second or third year, we're going to have a really good idea if there's something there. So it's a good arrangement for Serengeti from that perspective. The second portion of the agreement is the royalty provision. So Atty has a 3% underlying royalty on it right now, but Serengeti has the option to reduce the NSR by half and terminate buyout rights and area of interest provisions for an aggregate of 500,000 in cash or shares. We managed to keep a right of first refusal on the disposition of the residual 1.5% as well. So that's good for Serengeti for sure. So we'll zoom in here now and we'll have a look at where Atty is. So if we look at the map on the left here, you'll see our Croy Bloom property here, just west of Johansson Lake. We're up in the Tutigon, so Prince George is down to the south. And this is the UDS Atty ground here. You can just see the Kemess tailings facility is right here, and the mined out open pit is there. And so you can see that we're pretty close to the infrastructure there. Actually, it's better shown on this map. So here's Kemess South open pit. There's the tailings storage facility. There's a mill, airstrip, hydro line, a camp, all still on site at Kemess South. And they're currently going through and starting pre-construction on Kemess Underground, awaiting permits there. So the other property that we'll really focus on is Kemess East here, which was discovered in really the first holes were put in 2007 that hit KH0704 and KH0724, hit significant intercepts of gold copper mineralization in a porphyry system. So our exploration strategy more or less at Atty is to continue on from where Kemess East was left off. So you know, the next step in the exploration of porphyries really on Kemess would be the Atty property, and I'll explain that in a minute here. So when we're planning our exploration at Atty and thinking about how are we going to discover a deposit here and on UDS as well, we really need to look at the history of exploration success at Kemess. So Kemess South and Kemess Underground were really discovered about the same time, early, mid, late 80s. El Condor developed those, both those projects into viable operations. Between late 80s and early 90s, Kemess South and Kemess Underground were both defined. So Kemess South was in operation between 1998 and 2011, mined over 200 million tons, produced 300 million ounces of gold, and 750 million pounds of copper. It's now on care and maintenance, more or less, the infrastructure portion, and the open pit is actually being left open so that it can receive the tailings from Kemess Underground. So Kemess Underground is an interesting story as well. It was discovered about the same time as Kemess South, and really there was the gossiness zone at surface here that drew a lot of attention to the region in the first place. But the geochemical results and the fact that you could almost kick rocks on surface at Kemess South with native copper in them. That's why Kemess South more or less got developed first. But Kemess Underground was initially planned to be a open pit operation, and Northgate Minerals was furthering that effort in the mid 2000s, and they had an open pit mine planned there, but it actually failed to receive an environmental assessment certificate in 2007. So that decision actually came from the federal government in September 2007, and meanwhile they were about halfway through, just coming into the finish line of an exploration drill program at Kemess East, and they had already drilled a couple of holes there that looked pretty good, but they hadn't received the assay results yet. So Kemess North, at the time it was called the open pit, got declined, and basically Northgate went, okay, well, if this gets declined, EA, there's no point in us spending any more money here. They basically shut everything down, all exploration. They continued producing here, but they spent their exploration dollars in Australia, actually. So no exploration budgets or expenditures here at all from 2007 to 2013. So in 2013, Aurico Gold then had bought Northgate Minerals, came back and looked at the Kemess North deposit and went, well, if we focus on the high-grade core of the system, I think it would make sense for us to develop this as an underground operation. So they started putting things in place to make that underground panel cave system there, and started going through the required studies and permitting to get that approved. So they did receive the EA approval for Kemess Underground just last year, and they're currently going through permitting now. So how that relates to Kemess East then, so Kemess East was first drilled in 2007. They more or less knew there was something there, but all exploration was shut down. It wasn't until 2013 Aurico Gold went, okay, if Kemess Underground can work, then maybe we should have another look at Kemess East. So that's when they started drilling it off. So between 2013 and present, more or less, they've been able to define 113 million tons at 0.46 grams per ton gold and 0.38% copper. But the significance of that story is that there really hasn't been a lot of work up in this area since 2007 was the more or less when everything stopped. And it's worth it to note as well that when this got declined in 2007, it basically shut down exploration in the entire region. That coincided with the recession of 2008 as well. So things really shut down. So the point is that there's the knowledge that's been gained by drilling Kemess East is relatively recent. It's really just since 2013 that this thing has been understood, a resource defined there, and enough study work has been done to come up with a sort of a plausible idea on how this formed, and then of course where we could find more.
And Quinn, thank you very much for pointing out Kemess Underground permitting underway. That's I don't think that's particularly widely known. Has been lost on me in the past, but the potential to have a mine there in operations before 2020, that's something to pay attention to.
For sure, and Centerra now, so Aurico Gold started the idea of the underground. Aurico Gold and Alamos Gold merged, and the spin-out company Aurico Metals then took over the Kemess asset, continued furthering the development of the property, and then Centerra Gold bought Aurico Metals out in late 2017. So they are moving ahead, and you can see on this map here on the left, that's the infrastructure plan for how to get the ore out of Kemess Underground. So as far as I know, they're starting pre-construction down in the current infrastructure site with the hopes of getting the permits, and then they'll they'll drive the infrastructure in and get into production again.
Can you zoom in on that map a little bit?
Yeah, so here at Kemess, all the facilities are still there. There's a 25,000 ton per day mill sitting right here in this area. There's a camp, there's a shop, and administration and everything there. The open pit is available for tailings from the underground, which is part of the mine plan. There will be a conveyor driven like this. There'll be a short tunnel here and then a triple decline that will go underneath the deposit here to mine that out as a panel cave.
Right. I recall hearing about this conveyor that stretches over several kilometers. I love that.
Yeah, it's a pretty cool project. Their last feasibility study was quite positive, so I think we're all optimistic that they're going to make it happen. Okay, so this sums up what our strategy is for Atty. The North Kemess trend, which I'll explain in a minute, is dissected by post-mineral Horst and Graben shuffling of mineralized blocks. So the discovery of Kemess East was not a geochemical discovery. It was a coupling of a geophysical understanding, drilling, of course, and a detailed understanding of the post-mineral structure in the area. And I'll get into that here now, a little bit more detail, and show why that is important for Atty as well. So this is a geology map of the area. You have Kemess South down in the south here. Kemess Underground sits right about here. There's a zone called the Nugget Zone, which sits right in about here, which is gold rich, sort of a stratabound gold rich system. Right in this zone here is a zone called the Kemess Offset, which you can refer to some of Rico Metals press releases about the offset zone. It's a deeper mineralized system there. And then you have the Kemess East system sitting there. So that whole thing, this whole trend here, right between these faults, like this, like that, is pretty well all mineralized. They're different systems, but the systems are so huge, especially at Kemess Underground. That mineralized system extends, this is rough, but something like this, kind of thing like that. Then you have the offset zone that down drops like that, and then Kemess East. This whole thing is pretty much mineralized. So the thing I want to draw attention to are these faults as well. That. There are other faults that are roughly north-south that kind of cut like this. And those faults basically move that they cut that mineralized block after it was formed, and they move blocks up and down. So this would be a down drop block here. This is an up block. This is a down up block, and then this is a down drop block. And what that essentially looks like, I can show you in the cross section in a minute, is that while the mineralization is continuous east-west, all these blocks are sitting at different elevations. So up, down, that kind of thing. The other fault that then is really important to look at is the Kemess East offset fault, which cuts just like that. And movement on that fault, something like this. So up to the eastern block here is moved to the north, and the western block is moved to the south. So this fault really it's parallel to these other faults here that cut this mineralized zone here, and it's likely the same age. So all of this was moving up and down, a little bit of strike slip movement along these faults as well, all at the same time, likely in the Cretaceous or into the Eocene. So the main point I want to make here too with these east or north-south striking faults is that Kemess East offset fault, which I didn't make that point clear enough maybe in this slide, it cuts off the Kemess East deposit on the east side. Just like that. So if we look at that in cross-section, which this cross-section is basically coming right through like this, and then it's a long section, so they brought Kemess underground a little bit closer, but the section kind of goes like this through Kemess East. So if we look at it in cross-section, this is looking north. You have Kemess underground over here in the west side, about the 1150 level or something a little bit shallower than that. And then this is Kemess East. So the most striking thing that you can see is that the mineralized zone, which is basically everything in pink here, is cut off by a fault. Okay, this fault here. So what happens is Kemess East forms. It forms mineralized zones. It forms a mineral deposit. And then sometime afterwards, this Kemess East offset fault cuts the deposit off on the eastern side. And it down drops. Any of this mineralized stuff has been down dropped. So it's possibly down below here. But the thing is that when you drill through this fault, so none of these holes really show that, but there are holes that come through the mineralized zone and then pop out the other side into these Hazelton group rocks, the purple rocks. On the east side, you go from a mineralized, a healthy porphyry system here, and when you come out onto the other side, you're into barren Hazelton group volcanic rocks that are much younger and unmineralized and don't show any porphyry style alteration. So even these rocks up here, these Hazelton rocks, you do get certain amounts of alteration that occur in those rocks because of the mineralized system here. But you don't even see that over here. There's nothing over here. So these rocks here are, in my view, completely unrelated to the porphyry system that's sitting right next door. So I'll illustrate the significance of these faults a little bit more again in this chargeability cross section. So in 2007, Northgate Minerals had a large IP program completed across pretty well the entire Kemess claim block. It was completed by Quantech, and their system is called Titan 24 IP. So it's really high energy, deep seeing IP. And this is sort of a good section that basically cuts. It doesn't really give any context, so I'll scroll up here. That chargeability section more or less cuts right like this. So along that mineralized trend. So what it shows are that Horst and Graben style shuffling that you see. So there's a fault here, there's a fault here, another one here, here, and then there. So if you follow these purple blobs essentially, that you can see that they're down dropping to the east side. Like that. Now, it's important to note too that the elevation that it gets down to is 750 meters. Kemess East is actually sitting down around this zone here. Similarly with Kemess Underground sitting down there, kind of thing. So the response that the chargeability is getting here is not the mineralized portions of the deposit. It's showing a chargeable feature that sits above the deposits. So anyways, what a clear fault you can see here too is the Kemess East offset fault. And so this whole zone here is that mineralized trend. The whole thing is mineralized. And then you hit the Kemess East Offset Fault, and you come over here, and there's nothing. It's gone. So we're making the bet that that mineralized trend continues on to the Atty ground. So that's enough about Kemess. Now we'll talk about Atty and what the significance is of that understanding of post-mineral structural dissection at Kemess. What does that mean for Atty? And
sorry, Quinn, if I can just ask one thing too. What you're just describing there with the shuffling and the vertical offset, I understand that that's not, related to the east-west offset too, that is going to get into it, Addy. I just wonder about the timeline on, briefly on that, on the history of the understanding of Kemess Underground, Kemess East, 2007, 2013. Do you have a sense of when they really started to, for example, even that, the geophysics, the Titan line, when was that? Sorry, just to clarify.
Yeah, so the exploration really took big steps between about 1988, 89, and 2007 at Kemess. Started with El Condor and then continued with Northgate Minerals. They had huge exploration budgets. And they knew then that Kemess North at the time existed. But they didn't know about Kemess East, but they knew that Kemess North was there, and they knew that these faults were cutting the deposits. So this fault here, that one, is called the East Boundary Fault, and it cuts off Kemess Underground on the east side. So at that time, it was thought, well, the end of the world is here. So this is all mineralized, but this is nothing. They didn't see anything there. And that was in about 2002, 2004, that kind of range, where they had identified the deposit. They knew that this fault existed, and they also thought that there was nothing over east of that fault. So they didn't really know what to do about it. They didn't have that concept of this entire thing being a mineralized trend yet. They didn't really have that concept. They saw one porphyry deposit here, and some gold stuff over here, and that was about it. So in 2000, they did a first pass IP actually in 2006, and then 2007 when they hit it hard with that Titan IP that came across here, it really proved the concept that these faults are important, that they cut off the Kemess deposit here on the east side, but it showed that there's potential over here as well. That these blocks were just down dropped. They didn't move, or this wasn't entirely barren ground. It was just simply down dropped offsets of this system. So concurrently, that's when they started drilling, and they put a hole in at Kemess East and happened to drill deep enough to find it.
And any sense of that versus Kemess South?
Kemess South and the Kemess East and Kemess Underground are quite different. I don't think anybody really knows why. One idea that I was kind of playing with is that the Kemess South deposit lies just on the south side of a more or less east-west normal fault. And that fault has been considered to be likely the fluid pathway that allowed mineralized fluids to come up and form the deposit in the first place. Similarly, on the North Kemess trend, up here, there's a fault that runs roughly like this. That's also a normal fault, but it down drops everything to the north side. And I think that fault is the fluid pathway for this system, similarly to here. So essentially, big picture, what it looks like you have a horse here. So this is up, and then these blocks here are down and down. That's more of a structural sort of point of view, and why that would be the case is I'm not really sure. but the mineralizing characteristics at Kemess South and Kemess Underground and Kemess East, in fact, they're all very different. They're all calc-alkaline porphyries, but typical porphyries for the Cordillera in British Columbia, all formed about the same time, about 200 million years ago, in the late Triassic, early Jurassic. The mineralization and the intrusive stocks that they're associated with are cogenetic with the Hazelton group here. So there are some broad similarities, but when you get into the details, the targeting strategy is a little bit different between all of them, depending on where you want to go. So as far as Atty's concerned, we're really focused on Kemess East because it's cut off on the east side, but also because it has the most recent information available for exploration at Kemess.
Great. Thanks.
So if we look at Atty now, this is just sort of a zoomed in shot of the southern portion of the Atty claim block. And what you see here are just outlines of all the assessment work that's been done on Atty since about the early 80s. So the main points at Atty are the volcanic rocks that host mineralization at Kemess are exposed over most of the Atty property. That's not the case at Kemess East. Kemess East is a blind porphyry, or it's a hidden porphyry, in that it lies below a really thick cover of much younger rocks called the Hazelton group. But the deposit itself lies within an older package of volcanic rocks called the Takla group. And so it's really the Takla group volcanics that you want to be targeting when you're looking for porphyries in this region. And the Atty claim group is covered mostly by Takla group rocks, which is a good thing. In 2004, Finley Minerals drilled 7 holes at Atty. They were looking for a porphyry system, but they were looking for a porphyry system that looked similar to Kemess North at the time, which was going to be an open pit. That drill program intersected altered Takla group rocks, weak to strong zinc, skarn alteration and phyllic alteration, and anomalous gold and copper, and most notably zinc. The significance of this drill program is that at the end of 2004, when they got their assay results back, I'm sure the office was a little bit disappointed because they didn't hit a porphyry deposit in that first phase. They didn't hit really anything that looks like Kemess Underground. But when you look at the geochemistry and you look at the alteration in rock types in the context of the new Kemess East deposit, these holes actually look pretty good. But in 2004, Kemess East hadn't been discovered yet, so they had no context to compare the data with. In 2007, we talked about Titan IP that was completed at Kemess. That one line we looked at kind of runs something like this. Well, at the same time, Finley Minerals did a line of their own that cut right across there, like that. And we'll have a look at that in a minute because it shows some pretty interesting features. So the main point is that there's been a lot of work done at Atty. All of it was done prior to the discovery of Kemess East. So the key then to exploration at Atty is to look at all that historical data and put it into the context of what you see at Kemess East. Kemess Underground is important as well, but we think that if Kemess East has been cut off on the east side, that there's the potential to discover the eastern offset of the Kemess East deposit, and moreover, the eastern offset of that entire mineralized trend up here somewhere. So essentially, the exploration strategy is to continue where Kemess East left off. So here's a geological map. It's kind of an oblique view. So we're viewing from the south, looking north. Here's Kemess underground footprint of the extraction level at 1,150 meters above sea level. That's about 700 meters below ground level.
Quinn,
Yeah, go ahead.
if I could just interrupt you for a second and point out that I believe there's a photograph out there from the Finley Minerals days that's looking south from not far about where that arrow's pointing in a field photo.
Yeah, there is. There's a photo from the Atty camp, which is right about here, viewing this direction, kind of like this.
Great.
You can see the large Gaussian alteration zone for Kemess underground there, and there's another photo actually taken as well that kind of looks this way at this ridge. And you can see both. You can see Kemess underground, and then you can look up into the cirque here where Kemess East lies. So, you can walk there in, I don't know, 45 minutes.
Yeah, the proximity of that was really striking.
Yeah, it's great, and actually, that's a good point too. As far as access, there's a road that comes like this, and then continues around this knob like this, and then into Kemess East, and that was put in 2014 by Rico Gold at the time to get drills into the Kemess East deposit. Well, they had to ask. I was actually up there as a senior geologist at the time working for Rico Gold, and we had to ask permission from Finley if we could put a portion of the road on their property. So as far as access goes, you can drive all the way in here, and then the potential exists to just extend this road down onto the Atty ground as well. It's great because I think there's actually a couple of drills still sitting up here at staging at Kemess Underground too. So, I mean, if we want to drill it in the next little while here, there's 2 drills sitting there ready to go.
Wow.
Yeah, so, that's a good point really too, and it sort of points at something that the exploration that's being done in this area, the exploration teams that have been part of the Kemess East especially, programs would likely really like to have the Atty ground. If it was if it was Centerra exploring in this area, they would probably consider exploration on Atty as brownfields because it's the next logical step in the exploration for porphyries at Kemess. There's 3 porphyries now. We think there's more, but there's nowhere else to go. This area over here has been explored fairly extensively by the Kemess operators in the past, and they haven't found anything. The going opinion is that this fault here has moved this mineralized trend up here somewhere. It's not over here. This zone is out. It's not going to work. It has to be up here somewhere. So, let's see. Erase some of this and clean it up a bit.
Great. Love this functionality with the drawing on the maps and all this.
Yeah, it's pretty cool. Still getting used to it, but so the main points on this map to show are
doing a great job, Quinn.
More or less rock types. So Hazelton group, just consider those young. They're after mineralization. They're not what you want. Takla group is the host of the porphyry deposits. So you can see Kemess underground here sitting in a sea of Takla group here. That's good. It's pretty close to surface, so that's what you'd expect. Kemess East here is not sitting in a sea of Takla group, but the deposit itself lies in the Takla group underneath this big sea of Hazelton group. So I'll just draw a quick cross section just to illustrate. So there's the porphyry system here. Here's mineralization zone. This would be Kemess East. Here's the Takla group there. And over on top of the Takla group is the Hazelton group. So Hazelton group is younger than the mineralization in these porphyry systems. So when you see Hazelton group, you know you're not going to hit a porphyry. You want to be down in the Takla group. And that's what we have at Atty. This is all Takla. And the other thing is the Black Lake group, which is intrusive rocks, late Triassic to early Jurassic, intrusive sweet, and you can see just a little sliver, but down here. These rocks are about 200 million years old. The pink ones that you see on the map are not mineralized. They're barren, but they're the same age as the mineralized intrusives that occur at Kemess East and Kemess Underground. This pink blob here actually kind of continues down east-west, parallel to that mineralized trend. And you might have picked it out in an earlier geological map there. I should have pointed it out, but that's a large pluton called the Sovereign Pluton. Up here, labeled as Black Lake Group, this is what's called the Hilda Pluton, and it shares similarities with the Sovereign Pluton. In fact, they look like the same rock. But the thing is that the Sovereign Pluton is cut off on the east side by that Kemess East offset fault, which basically seems to cut everything. Cuts the Sovereign Pluton off on the east side. It cuts Kemess East off on the east side. And the idea is that the Hilda Pluton is actually just the eastern extension of the Sovereign Pluton. So if that's the case, that gives us a pretty decent idea of the slip along the Kemess East offset fault, which would be about 1 kilometer of east side to the north. So if that's the case, then Kemess East also cut off on the east side. It's been moved up about 1 kilometer, which would put us right about here. So that's more or less what I wanted to say there. What we'll do is we'll look at LiDAR image of the same area. And what I've done is I put the 2004 drill holes here that Finley Minerals completed. There are 5 collar locations there. There's actually 7 drill holes drilled from 5 pads. And they were drilled at about a -45 into the hillside, more or less targeting what you can see there, this gossinous zone here of phyllic alteration, quartz, sericite, and pyrite. Classic looking, similar to what you see right above Kemess Underground, which you can see there. This whole zone. So again, what they hit, altered Takla group rocks, some phyllic alteration likely associated with that gossin there, and most importantly though, zinc skarn alteration and zinc mineralization. So here is a snapshot of the 2004 Atty drill results, and you can see anomalous zinc here, 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 a lot right here above detection, above 10% zinc right there, and that's associated with lead, some moly, was at 0.1, close to 0.14% copper. No gold, but you're seeing gold up in this zone here. So this geochemistry is fairly classic of what you would call a zinc skarn alteration in the Takla group. And that's important because when you look at the chemistry of Kemess East, you see the exact same thing. You see this zinc zone associated with some copper, lead, sporadic low-grade gold here. And that tells you that you're getting close to just the outboard zone of the Kemess East deposit. And that's what they intersected in 2004. Now, again, of course, in 2004, this was insignificant. They weren't looking for a zinc mine. They were looking for a gold copper mine, and they didn't really hit anything that would have been economic. But now that Kemess East exists and it's discovered and that data is now public, we can look at this and go, holy crow, this looks very similar to what you see above Kemess East. what we'll do is we're going to have another look at this image. We're going to focus in on this line here, which is the surface trace of the 2007 Titan IP line that was done by Quantac. So there's the slice. There's the IP section there. There's the Kemess East offset fault, well defined. And then here's the section. So the Kemess East offset fault is well defined on surface just by geological mapping. It's defined by the drilling that was done at Kemess East. Larry Dykow in the late 90s and early 2000s, he published a map in 2001 that's really the standard for exploration in this area. Exploration geologists at Kemess use that map religiously. And he has this Kemess East offset fault outlined on surface as well, and it's lined up really well with the drilling that's been done at Kemess East. Here, the reason it's drawn in section view here is because the resistivity, which you don't see, the resistivity anomalies come up something like this. Very sharp resistivity like that, and another resistivity anomaly like this that picks out those structures really well. I didn't want to show the resistivity on here as well, but I just drew the faults on. So there's the Kemess East offset fault. Here's another unnamed fault here. And then here's a significant chargeability anomaly. So this is exactly what we would hope to see if we were looking for the eastern offset of Kemess East. So Kemess East is over in this block over here to the south. The Kemess East offset fault cuts the deposit off on the east side. It moves that eastern portion of the deposit north onto the Atty property, and now we see likely the upper portion of the Kemess East system in this chargeability anomaly on the east side of the Kemess East offset fault. So in 2007, when this line was run, Kemess East hadn't been released yet that they had hit some significant mineralization there. So this chargeability anomaly really didn't, I mean, it's a great anomaly, but it didn't have really any solid context for what it could mean. So basically, for us, this is about the 1,500 meter level, 500 meters depth, so our target would be somewhere in this zone, but most likely below, something like that. So that's our target zone.
So a question for you about that, Quinn.
Mm-hmm.
Depth-wise, and well, lots of questions, I guess. You alluded briefly to Finley and why they didn't drill down there. I guess with those kind of depths and not a real solid understanding of the ideas you have now, I can understand why they wouldn't want to take that chance.
Yeah, absolutely. I mean, Kemess North at the time is exposed more or less at surface. You can see the phyllic alteration zone at surface, all the rusty colored rocks creating a gossan that's several kilometers long, half a kilometer wide. And they didn't, you don't see that at Atty. So in 2004, to step from what was known at Kemess North and take that information and explore on Atty was too big of a step. There was too many unknowns there. First of all, there is only a small gossan exposed at surface at Atty, rather than this huge alteration zone that you see at Kemess North. And the holes they drilled, while they were based on older shallow IP, they didn't, yield the result I think that they were hoping for. So they would have had to drill a bit deeper in order to have a good idea. But at that time, if it wasn't something that looked like Kemess North could be easily open pittable, then it was kind of a long shot. But now that Kemess East has been discovered, and because the drill sections are so long, the drill holes are so long, you can really see the changes in the trends of geochemistry and alteration in lithology from a really high level all the way down deep into the deposit. So you have a lot of data there now, or we do, that we can look at that's public, to build more of a robust exploration model. And also now the step, from a known deposit to the unknown is a lot smaller. The step from Kemess North in 2004 to Atty was a big step. That was a big jump. But the step from Kemess East now to Atty it's kind of like baby steps. It's more plausible. And we have a better exploration understanding of the area now that Kemess East is there.
Great.
So this is more or less our target zone. Would be anywhere from 150 meters below surface here, and who knows, down underneath that chargeability anomaly there somewhere. So that's our zone here. So the one thing actually I didn't mention in the KEG presentation in Kamloops is really make the point that there is some distance between where these drill holes were drilled and where this IP line is here. So this is a significant charge or a significant target area here. This looks very compelling. The drill holes were drilled about 800 meters or so to the north, but the alteration and mineralization rock types that they saw there, while at the time were likely disappointing, now when you put them in the context of this chargeability feature and Kemess East, is almost exactly the alteration and mineralizing zonation that you would expect to see if there is a porphyry system sitting here that's mineralized. These holes make complete sense with as far as the geochemistry goes. They're about the right distance away. The depth of penetration of those holes, makes sense as far as what you would see in this upper sort of portion above that chargeability anomaly. Now, I'm making a lot of assumptions here, but there's also, these systems are fairly well defined, so you can get a pretty good idea about what you should expect when you're outboard of a mineralized porphyry system. So we don't know that one exists here, but we do know that the alteration and mineralization in this area is what you would see this far away from a porphyry system.
Yeah. And those holes were pointing off in the northeast, if I remember correctly.
Yeah, they were drilled pretty much right into the hillside here, towards the northeast. Fairly shallow angles as well, so they didn't get down deep. They were kind of more into the hill, which was fine. I mean, of course, that what they were looking for, they were focusing on the reason why this Gossan exists there. But what we would want to do is come towards the south, come towards this chargeability anomaly and put holes, not vertical, but close to vertical down. And we want to get into not deep, but we want to get below surface. We don't want to be up on this hillside. We want to be down closer into the valley.
Well, an exposed alteration, always a good thing too, right?
It is. And this alteration here, that Gossan zone, that Phylix zone, again, is what you would expect to see outboard of a porphyry system. So they stopped the holes at about 300 meters, a little bit more than 300 meters. The actual depth from surface would be about half that, about 200 meters or 150 meters below surface. In 2004, that was kind of deep enough. You didn't want to go any deeper than that, because if you didn't hit it then it's probably too deep for it to be economic. But the times have changed now. Kemess North in 2004 is now Kemess Underground in 2018. Kemess East, if developed, will be an underground as well. And anything on Atty would probably be an underground system. But the important point here, though, too, is that our target at Atty here is deeper than Kemess Underground. Maybe not by much, but a little bit deeper than Kemess Underground. And we know that because we don't see a exposed phyllic zone at surface. But it's going to be shallower than Kemess East because we do see tackle group rocks at surface. And those tackle group rocks are altered. So we're looking in the, in about this range, really. I mean, that's again where this IP anomaly makes sense as far as a depth of system hypothesis is. Okay, if this makes sense, we see there might be a little bit of a surface expression of a phyllic zone here. So maybe this is the phyllic zone and this is the potassic mineralized zone here at a depth that's shallower than Kemess East, but slightly deeper than Kemess Underground. That's more or less what we would expect.
And for people who may not be familiar with Serengeti and everything you guys have been doing at KWANIKA there, it would seem to me you've had some success in the last 3 holes, and looking forward to some excitement in the next holes at KWANIKA, in terms of shaping up the existing underground resource there and kind of finding new areas of it that may be a little more compelling than others. Just to encourage people, don't be scared of underground exploration work here.
Yeah, absolutely. That's underground is really where the industry is going, and it's for various different reasons. At least in British Columbia, a lot of the deposits that you can walk along the ground and at surface and find have been found. The deposits that are slightly deeper than surface that you can mine with an open pit have been found, but a lot of them won't make it through the environmental assessment process because the environmental impact from open pit mining is becoming too high to be worth it. So I think as we go forward here now, of the large deposits, of porphyry deposits in particular, developed underground almost as a preferred method to open pit mining. The development costs are a bit higher, but you can focus on the high grade and do it with a much lower environmental impact. So I don't think people should be afraid of looking at targets that may potentially be underground scenarios in the future, because it's just really the direction the industry is headed.
And we discussed before how Kemess Underground, obviously underground operation there, and talking about the conveyor belt to move ore and waste rock, everything. As you say, the future of a lot of the industry moving towards underground. It's great.
That's right, and the future at Kemess is going underground as well. Once that infrastructure is in place to start extracting material at Kemess Underground, it's not too difficult to fathom that they will then drive a decline underneath and put an extraction level in underneath Kemess East. That this area in particular is going to be very well developed as far as underground mining techniques and infrastructure. So, considering that if we do find something at Atty, that it would likely be an underground. It could be open pit, but most likely underground. I don't think that's really a slight on the project, considering right next door is all that infrastructure. I was going to make one more point, but I can't remember what it was. So maybe we'll move to the next slide. So more or less a summary on Atty and UDS. Now, we didn't talk about UDS at all, but there's a significant story there as well. Both land packages combined are close to 6,800 hectares. And this point is the big one, is that they're relatively underexplored, considering recent developments at Kemess, which are the positive feasibility of developing Kemess underground as a panel cave, and the discovery and delineation of 113 million ton resource at Kemess East. So we need to work this area and put this into the context of this. This is the main target area that we just spent, I don't know how much time here talking about. Also is the on the UDS ground, this circle here is the area of the 2017 drilling program that Serengeti completed. These holes identified a strong, pervasive quartz sericite pyrite phylic zone that appears to vector or trend onto the Atty ground to the northwest. At the end of that program, we did our, put all the data together and did our interpretation and went, man, this is too bad because it looks like it's going up over here onto Atty, but that's not a problem for us anymore now that we've have the option to explore there. So we're excited. We're going to come down in this area as well and have a look around, because this area plays into that whole story of the dissection of this mineralized trend, and indeed the dissection of the Kemess South deposit as well. There's a lot going on in this area. Again, this is cut off there by that fault, but Kemess South is actually, which lies here, is actually cut off by a fault there too. And the eastern portion of Kemess South has been cut off and moved somewhere we don't know. So there's really the next, in my mind, the next logical step, especially considering that this area here has been explored and have turned up not much. The next logical step in exploration for these porphyry systems, 1, 2, 3, is Atty. It's up here somewhere, hopefully. There's no reason to believe that there are only 3 porphyry systems at Kemess. That was the initial thought when they found Kemess underground and it was cut off. They went, okay, well, maybe that's the end of the world. But hey, then they found that. So that's number 3. Cut off again. Maybe that's the end of the world. No, I don't think so. It's been moved.
Great stuff, Quinn.
Right on. So we're obviously really excited about this.
I wonder, I guess you've got a slide about plans and stuff. I wonder when you'll have some certainty, or how much certainty you'll have, really, even before you go out in the field and start doing some work there.
Certainty as far as exploration targeting, or?
Yeah, and scope of work plans.
Yeah, so because sorry, I'm scrolling around here. Just want to go back up to one of these maps. So because the agreement with Finley is fairly light at the beginning, it gives us a good opportunity to get into this sort of, I don't want to say slowly because I think people cringe when they hear the word slow, but slowly, because we want to have a really detailed understanding of everything that's been done on the Atty claim group up until now. We want to make sure that we're not missing anything as far as hints on Kemess. So we want to dig through all that public data, and not that we haven't already, we've been doing a lot of that, but just really soak the essence of the work that's been done so far up. And then because the option agreement is fairly light from the beginning, we'll spend $300,000 filling in this IP here. We'll do some lines like that. We'll probably do a line right along the claim boundary, something like that. We'll probably do a line up here along the Kemess East offset fault to try and get some north-south idea. There's also target areas up in here, which we didn't talk about. We're going to put a line across here as well, because this area here feeds into that whole structural story. And if you look at it like a puzzle, you can't move this block without looking at this block, and you can't, understand what's going on in this block without looking over here, for example. So we'll fill in the IP. We're hoping to get a very well-known mapping porphyry, BC porphyry mapping geologist up at Atty this year to map in detail the Atty property. So we know, with again putting Kemess East and Kemess Underground into perspective, we want to look at these rocks again, given that new information. We're going to relog and resample the old drill core here. So those holes were only sampled selectively. So we're going to relog the whole thing again in the context of Kemess East, and we're going to resample the whole 1,650 meters of it with multi-element ICP, so we can really get a good idea of the alteration characteristics there. And then we're going to have a look at the old geophysical surveys as well, and bring all that data in and try to build a geophysical model with the old data that already exists, because that's a cheap way to do it before we get people on the ground. We'll remodel all of the old geophysical data and see if that's telling us anything as well. So the point is that before we get a drill up here, we want to have a really good understanding of what's going on, because once we start drilling, obviously our costs go up. That's of course when you find things, but you're not going to find it if you drill in the wrong place. So we want to take a logical, stepwise sort of approach here, and not get really overly excited and throw a drill in there too early.
Possible to drill there year round?
No, it's the season really starts, Kemess East. We were, I think the earliest we had drills turning up there was maybe mid-June, end of June, and that was after coming in here and blasting all of these cirques get big cornices of snow on them. Not so much this one actually, but cornices up there you have to blast, get those down there, and then bring an excavator in and open up the road to get in there earlier. But really that only buys you about 2 weeks anyways, at huge cost. So Arico was able to afford to do that. We're not interested in spending all of our money blasting for avalanches. We'll just wait 2 weeks kind of thing and go in likely mid-June, end of June, and then you can explore and drill there into easily end of September into the mid-October. No problem.
Well, and a long history of work at this area too, right? Before Kemess discoveries, I believe some surface showings maybe 50 or 100 years ago that have drawn people to the area. So a lot of stuff for you to pour over.
Yeah, for sure. I mean, this alteration zone, like I said, I think earlier, that's what really drew people to this area to begin with.
Really?
Yeah.
Is it really that area that Finlay drilled?
Sorry, go ahead.
Is it really that area that Finlay drilled that was one of the main alteration areas showing at surface that really started to bring people to this whole area?
Well, it was this area here over Kemess Underground that was really the big one. that drew a lot of attention initially. But John Baraxo, who has held, he's Electrum Resources Corporation, holds the NSR on Atty, and sits on the board of Finlay Minerals. He staked Atty. He worked on Kemess Underground during the initial discovery phase in the 80s from a geochemical standpoint. So he, in his prior career, John was sort of a regional geochemist looking at the geochemical signatures of these huge systems like this, and that's what led him to pick up the Atty ground in the 80s. Was
Great.
looking at the geochemical patterns, and that's what we didn't talk about in this presentation is geochemistry, but we will in a subsequent presentation. He looked at the geochemistry of the Atty ground and went, wow, it does look, it has the same signatures as the Kemess area does, so he claimed it.
Wow.
So Atty, this ground here is seen, partly just because of its proximity to Kemess, but also because it does stand on its own two legs as far as what the data that you see there. It's had a lot of work done on it over the years, but again, none of it since Kemess East was discovered.
And maybe one question about that satellite image. Not sure exactly how to phrase it, but I wonder about if the shape of the mountain there, as we're looking at it, gives you any sense for structural upshift or downshift, all that stuff.
Kinda. There's sort of been, well, I mean, the easiest thing to look at really a lot of the time is topography. So you try to get an idea of the structure just by looking at the topography. But this is an easy one, looking at the Kemess East offset fault, because you can actually go up here on the ridge in this area and you can see the fault cutting through that ridge there. Similarly, this ridge that runs sort of this direction here, east-west roughly, you can see that that's likely a large normal fault there that's down dropped this whole northern portion down, and this up portion to the south is relatively up. What's funny too is that you have a fault here. You can see there's a cut in the ridge there as well, and then this ridge, like all these other ridges, continue on like that, but this ridge doesn't, just stops there.
Yeah.
So that's that's kind of interesting too. So there's probably a fault in here somewhere. In fact, we could get into the details of it, but we do know there's a fault there, and we know there's a fault here as well. We don't know if they're the same, but that has implications for our targeting as well, but not necessarily a bad thing. So
yeah.
Yeah, so you can see as well. I mean, big picture too. You can see there's a fault here called the Atticelli fault. Another fault cuts down here like this called the Saunders fault. And again, so Saunders fault movement, something like this. I don't know what the movement is along the Atticelli fault, but the whole area is really typified by these roughly north-south trending faults like this, just the same as the Kemess East offset fault. There's another one that cuts through here. There's one that cuts off Kemess Underground on the east side. There's another one that runs right through there. Those faults are, understanding the movement of those faults is imperative when it comes to looking for another system.
Yeah, and that helps me understand why you say, that you want to have a firm understanding of everything that's been done here before you really get out there and get drills turning.
That's right.
Great, thanks.
Perfect. So I think that's mostly what I wanted to say. We can have a quick look at the Search 3 staking that we did as well. So again, we staked 8 properties in late January or early February, um, more or less based on the Geoscience BC Search 3 survey that was completed last year. Um, so just to orient everybody again, so here's our Croy Bloom property. Here is Centerra Gold's Clio property, which was held by Kiska for years, subsequently drilled with Teck. Then when Rico Metals bought out Kiska, they acquired this, and now Centerra. That's Clio, and then here's the Atty UDS there. So we picked up 8 properties. Here, Far East of Forest, that's an interesting one. East Niv, which actually is a little bit bigger because we've grown the size of that one. East Copper King, which lies just east of Pacific Empire's Copper King project there. The RJ, West Goldway, ET West, Notch, and the TRUM or TRUM. So I'll just pick a couple and talk a bit about them. So the TRUM property is a bit of an anomaly, actually, because it's got strong nickel and cobalt. We're not a nickel cobalt exploration company, but we are opportunistic. And since we're in the copper business, of course, we want to maybe keep with the battery idea, and nickel cobalt, of course, is used in batteries. So the TRUM, which stands for Triassic Ultramafic, down in this area basically covers Triassic Ultramafic plug, and it's associated with really high nickel cobalt in soil, stream sediment samples. Those samples are in the upper 50th highest nickel values in the province. So it was open. We couldn't help ourselves. We picked up that entire magnetic anomaly that's associated with the intrusive plug, and we're going to get out there and have a look around and see what's going on, because it looks like there hasn't been a lot of work done on that in the past. But with the new Search 3 data, we were able to actually see the resolution. The resolution was good enough to actually see that intrusive plug, which was not visible in older data. So that's why we picked that up. We also picked up a property called the Far East La Force, which is on the extreme north end now, just east of the Atty UDS and Kemess area, basically sitting in the same type of rocks. There's a few faults here that seem to cut things up a bit, but strong magnetic anomaly there. We got 200 grams per ton silver in stream sediment sample on the property, which really caught our eye. That's pretty impressive, and fairly, I can't remember the number, fairly high copper values as well, in an area that we have no reason to believe would not host a porphyry system. It's in the right type of rocks. The rocks are the right age, and the mineralization is there. So we're going to go up there and have a look. We also picked up this East Niv. Again, it looks small, but it's actually, this one is only covering about 150 hectares. That box, we actually have about 943 hectares of ground there. That was initially held, or most recently held, by International Samuel, who owns this ground here, Alex Walcott. They had this ground. They actually ran 2 IP lines across there, and picked up a really nice chargeability anomaly right below the Takla Hazelton contact, which for anybody who's familiar with Jeff Kaiba's red line map, is a map basically that shows a contact between the Hazelton group and the Takla group, which is a critical area when exploring for porphyry deposits. That line basically cuts right through there like that. Same with that Atty. That line goes like that, and Kemess as well. So we want to be on that line. East Niv is on the line. It has significant chargeability anomaly just below at a porphyry scale in the Takla group. And then for the rest of the properties, I won't go into detail, but all similar characteristics. Our strategy here was to basically compile all the data historical data on this entire region. We didn't know where the Geoscience BC Search 3 data was actually, where the survey was actually flown. So we thought, okay, well, it's somewhere in this area. We're going to gather all the data, and here we're going to focus on higher grade copper and gold in soil regional data. Have a look at the older aeromagnetic data and see if we can pick out some target areas, which we did. And then once the Search 3 data was released during Roundup, we loaded those layers on to our existing targeting models and picked any areas where we could see higher resolution targets sort of within the backdrop of historical geochemical data. And that's what we ended up with for these
That's
8
great.
properties.
Thank you for providing that kind of context there. I wondered if the Search 3 stuff was kind of enough on its own to guide that staking that you did, or it's good to hear that you had some additional layers to consider.
For sure. Yeah, our first pass was looking at lithology and rock type and age of rock types, considering how porphyry deposits form, what age they are in this area, and then start loading on the layers, the geochemistry, geophysics, and getting a really good understanding of how everything works in this area before the Search 3 data was released. But I think it's also, we've been working in this area for a long time as well. I mean, we've had Croy Bloom for a long time. We've had numerous properties in this area. So we're not starting from scratch. We know this area fairly well. This is kind of our backyard. But with that extra deposit scale, high resolution, magnetic and radiometric data, we're able to dive in right at the deposit scale and pick targets that have the best chance of hosting porphyry systems.
Great. And maybe if you could just show me again the long section geophysics of Kemess East, Kemess Underground there versus that line on the Atty. It seemed very prescient or foresighted of Finlay at the time to, run a line on their ground when the Titan was in the neighborhood there.
Yeah, absolutely. I mean, when you look at the response here that they got at Kemess, would you like me to put it into sort of plan view context again?
Well, and just to clarify that those are, the same, they're using the same machinery to do that survey there as on the Finlay ground.
Yeah, I mean, so I was working as a student geologist at Kemess in 2007 when these surveys were done, and this line in particular I laid out as a student. I still remember standing right here having lunch when we laid this out so that the line cutters could come in and cut any line that needed to be done, which actually on this line there wasn't much because there's not much vegetation at that elevation. But laid out those lines, and then Quantec came in with their crew and laid out the survey and did the survey. And I remember too, at the end of their program for Kemess, I remember seeing them down at Atty doing the line on Atty as well. So I assume that both Northgate Minerals and Finlay Minerals got their data about the same time. It's the exact same process. And that was the whole reason why Finlay Minerals did it on Atty at the time, because this is a very expensive survey. It just made sense. If they were doing the surveys at Kemess, then they would see if they could piggyback on that program and get line down on Atty as well.
Yeah. And with the adjoining roads going over the property and everything, clearly they were, good neighbors to each other and all that good.
Yeah, they were. A lot changed though after 2004, 2007 when everything shut down when Kemess North was declined in 2007, it really gutted exploration in the whole region, and it took. I mean, I think some companies just had a really hard time coming back from that. Um, so, Arico Gold was able to do it because they were able to throw the money at it, and they had the clout to come back into the region and keep. I mean, of course, because they had Kemess South in operation, so it was easier for them more or less to, okay, let's roll an exploration crew up there for 4 or 5 months. Let's get a couple of drills on site, and we'll see if there's any merit to Kemess East. It was easy for them to do that because they basically have a city sitting there that they can stage from. But for companies like Finley, once Kemess North got declined, it just crushed them, and it was really hard for them to, well, first of all, justify to the market, but also plan a worthwhile exploration program that wasn't going to completely dilute their stock. So again, in that sort of that taking steps sort of thing is, Arico took those steps for everyone else. They made the step from Kemess Underground to Kemess East. That was a big step, and now Serengeti now in Finley, we don't have as big of a step to make between Kemess East and the next discovery.
And the discovery at Kemess Underground, was that below the chargeability high there in this cross section?
Yeah, it kind of. So this chargeability high here, pretty much, well, and over to here as well, pretty much defines the phyllic alteration zone at Kemess Underground, which is the zone of leaching after the deposit's formed and the whole thing, the system is starting to cool down. So imagine that you have porphyry stock sitting here like that, and then it alters all these rocks here, and it alters this stuff here, and there's probably even some copper and gold mineralization in here. But as this system starts to cool, all these fluids start to flow back into the system like that, and this system ends up being sort of like a leached zone. So the copper gets pulled back into the deposit here, which is good for the deposit because it enriches it, but it sucks all the metal out of this zone, leaving just pyrite. So that's what you see there. High chargeability, think pyrite. This is a high pyrite zone. This is a high pyrite zone again. This is all mostly strong pyrite zones. The thing with Kemess East, though, is that Kemess East, I mentioned that the Kemess deposits, they're similar from a really high level, but quite different when you get into the details. And Kemess East, the difference between this and this is that Kemess Underground has this huge phyllic zone that you can see on surface. But it does have a big phyllic alteration zone. Kemess East doesn't. There's not really a large, well-defined phyllic alteration zone at Kemess East, and there's various different ideas of why that might be, but you don't really see it. So the question then is, okay, well, what's this chargeability anomaly that you're seeing? If it's not a really strong phyllic zone, if Kemess doesn't have a phyllic zone, well, then what's this? And I think the answer is it's a metal-rich zone, a highly chargeable zone essentially, but it's not a phyllic alteration zone. So,
yeah.
But the reason I put this section on here is again just to illustrate the structural dissection of that continuous zone. But the actual deposits more or less are like here's Kemess Underground. The Kemess offset zone is way down here, like that kind of thing. And then Kemess East would be like that, and then cut off by default. So,
and holes in that chargeability high, the metal rich zone that you're describing at Kemess East there, that's not, despite the fact that it's a metal rich zone without pyrite driving the chargeability high there, it's not copper driving the chargeability high. You don't think that's not the main part of the deposit there?
No, the main part of the deposit is down here, kind of like this. My best guess is that this zone is maybe an outer propylitic zone where you get some significant pyrite abundance here, but it's not the phyllic zone. So
Yep.
the phyllic zone, if Kemess East is here, should be sitting something like that. And there is a small zone there that sits something like that. But again, that's below the depth of penetration of this survey.
Yeah.
So you wouldn't see it. But so this zone, if that's true, if this is like a metal or pyrite rich propylitic alteration zone, outboard alteration zone, then it would be sitting up here somewhere at Kemess Underground. Well, it's been eroded off.
Mm-hmm.
Something too that I would want to mention is this anomaly, because I think a lot of people might go, wow, you know, why are you exploring it? That's probably the offset of Kemess East over there, and that's on Centerra's ground. You know, there could be some doubt put into our model there. And the thing is that my answer is no, this is actually the Hilda Pluton here. It's barren. In 2015, again, all that data is public. 2015, Arico Metals drilled some holes in this area to see if there was mineralization on the north side of the Hilda Pluton in the same way that there's mineralization on the north side of the Sovereign Pluton in this area.
Yep.
And nothing was found. It was the tackle group rocks are relatively unaltered, no metal. Where the Hilda Pluton was intersected, it's unmineralized. This would be basically pyrite zone in the Hilda Pluton, similarly to there being a pyrite magnetite zone in the Sovereign Pluton. So the answer is no, this is not an exploration target. It was in the past. There have been holes put here 2015, but also 2006, 2007. During the exploration of Kemess East, holes were put over here as well to try and see, well, okay, maybe it extends all the way over here, and it doesn't. It looks like that block, this block here has been moved up. So
Yeah.
because I didn't actually show that earlier, I would like to point that out. So this is the Sovereign Pluton here again, barren. It's actually on new maps from Arico, kind of comes something like this.
Huh.
Okay, and that's barren. Everything north of it, east-west, is the mineralized corridor. This is the same age as mineralization, but it's not mineralized. And then here's the Hilda Pluton, something like this.
Yeah.
And holes were drilled here, right in it, here, all over the place over here to try and find the extension of this zone, and they didn't find anything. The idea is that this actually continues more something like this. And there's just a small dike that continues up there.
Yeah.
But it's the eastern cutoff of the Sovereign Pluton here, which gives us our slip direction and displacement on that.
Yeah, that seems pretty clear, doesn't it?
Yeah. Yeah, which again would make the mineralized trend something like this.
And the only thing I might point out about that in addition is that there's a fault nearby to the east there that runs in the other direction, and that might be responsible for some of the twisting that you're seeing in that intrusive. You see how in the west of the fault it's really kind of running northeast, and the other one is kind of running southeast. It could be that you're not a geologist here, but it just occurs to me that you've talked before about the fault that runs in the other direction, parallel to the Kemess East offset fault, and I wonder if that could be causing some twisting, reorientation, and things.
Absolutely, yeah. So this Saunders fault, which is a large regional fault like this, is interpreted to have dextral slip on it like that. So yeah, you're right. There could be some rotation in here where this block here has been rotated. That.
And that idea is important too when it comes to you guys targeting at Atty. You don't want to find out about that, after you get up there and drill. And
That's right.
There may be historical information to help guide you in understanding that.
Definitely.
Well, thanks very much, Quinn.
You bet. Well, that was fun.
A substantial conversation for people here. Probably goes over the head of many people out there who follow the juniors. but I think it's appropriate for you guys to, provide this kind of deep dive. I think just looking at the deal you did with Posco Daewoo for KWANIKA speaks to the depth of technical expertise in Serengeti there, and the fact that there is an audience out there for the full story.
Yeah, definitely. Well, it's well, here I tried. I didn't have the idea of going into the extreme details of this when we started this, but that's where things are found. It's in the detail.
Yeah. And I'm sure that there are many more details that we didn't even, cover, that people can contact you to discuss further. Maybe if you could put up the last slide there with your contact info, please. Great. I invite anybody interested to reach out to the company there. I'm sure they're busy, but they'll do their best to get back to you. Thanks very much for walking me through everything here today, Quinn.
Yeah, thanks a lot, Peter. It's an excellent idea.
Until next time.
Take care.